Welcome to aminacademy.com. In physics, let us discuss about longitudinal and transverse waves. You may see that motion of a mechanical waves involves oscillations of constituents of the medium. If the constituents of the medium oscillate perpendicular to the direction of the wave propagation, we call the wave as a transverse wave. If they oscillate along the direction of wave propagation, we call the wave as longitudinal waves. A mechanical wave is a wave that is an oscillation of a matter and is responsible for the transfer of energy through a medium. That means medium is necessary to propagate mechanical waves. The distance of the wave's propagation is limited by the medium of transmission. In this case, the oscillating material moves about the fixed point and there is very little translation motion. Look at this figure. Here, suppose a still water, you drop a pebble on it, the surface. What happened? The ripples created around the point where you drop the pebbles. It's a transverse waves example. Longitudinal waves is a sound wave. That sound waves vibrate through the medium and reach the point where it should go. In physics, a mechanical wave is a wave that is an oscillation of a matter and therefore transfers energy through a medium. While waves can move over long distance, the movement of the medium of transmission, the material is limited. Therefore, the oscillating material does not move far from its initial equilibrium position. The mechanical waves can be produced only in medium which possess elasticity and inertia. There are three types of mechanical waves, that is a transverse waves, longitudinal waves and surface waves. Some of the most common example of the mechanical waves are water waves, sound wave and seismic waves. Like all waves, mechanical waves transport energy. This energy propagates in the same direction as the wave. A wave requires an initial energy input. Once this initial energy is added, the wave travels through the medium until all its energy is transferred. In contrast, electromagnetic waves require no medium but can still travel through one. That means mechanical waves need medium, but electromagnetic waves require no medium, but can still travel through one. There are three types of mechanical waves: transverse waves, longitudinal waves, and surface waves. Some of the most common examples of the mechanical waves are water waves, sound waves, and seismic waves. Here, this point is important here. Now, further explanation of the wave. A wave is a disturbance that propagates energy from one place to another without transporting any matter. A general example would be a stone hitting the surface of the water and creating ripples that travels in the shape of concentric circles with its radius increasing until they strike the boundary of the pond. There are various types of waves and two of those would be longitudinal and transverse waves. Now we'll discuss about the difference between longitudinal waves and transverse waves. Look at here. Suppose a spring is one end is fixed with one surface, that is a wall. Other, you pull the spring and release, so it's vibrate like this. That is longitudinal waves. Suppose if you make movement like up and down, that it forms a transverse waves. In longitudinal waves, the medium or the channel moves in the same direction with respect to the wave, like here. Here, the movement of the particle is from left to right and forces other particles to vibrate. Is vice versa. It goes, the waves travels like. In a transverse wave, the medium or the channel moves perpendicular to the direction of the wave. Here, the particles move up and down as the wave moves horizontally. Particles move up and down as the waves move horizontally. Now let us discuss further about the difference between longitudinal and transverse waves. In longitudinal waves, the medium moves in the same direction of the wave. Transverse waves, the medium is moving perpendicular to the direction of the wave. In longitudinal waves, it acts in one dimension. Transverse waves, it acts in two dimensions, that is xy direction. Here, the wave cannot be polarized or aligned. Longitudinal waves cannot be polarized and aligned and cannot be aligned. The transverse waves, the wave can be polarized or aligned. Longitudinal wave, this wave can be produced in any medium such as gas, liquid or solid. This is a longitudinal wave. Transverse wave, this wave can be produced in solid and liquid surface. Now, longitudinal waves, the earthquake P wave is an example of longitudinal wave. Earthquake S wave is an example of transverse wave. It is made of rarefactions and compressions. That means this is a rarefaction is enlarged, compression is compressed. Longitudinal waves consist of refractions and compressions. It is made of through trough and crust. Here, this is crust, this is a trough. Upward point is crust, downward point is trough. Now, these are some explanation about types of the waves, that is longitudinal and transversal waves. We have done. Please subscribe our YouTube channel.